In this video, we're going to learn how to identify different types of chemical reactions. So a synthesis reaction is when two atoms or molecules combine to form a larger molecule. So the way we can represent that is, A plus B makes AB. If we take a look at a real life equation, you would see something like this, like H2 plus O2 makes H2O. Now this equation isn't balanced, so we would need to balance it. So there's two oxygens here, but only one there, so we put a 2 there. Now we have 4 hydrogens, so we need to put a 2 there. So that's a synthesis reaction. You can see that there's two smaller atoms, or two molecules here, and they're fusing together to form water. A decomposition reaction is when a molecule breaks down into two or more parts. So we have AB breaking down into A plus B. So an example of this could be even just the reverse of what we just wrote. So if we have a water molecule being separated into oxygen and hydrogen, that's an example of a decomposition reaction. So another way to recognize it is if you have, one reactant becoming two products. So we also need to balance this equation. So we only have one oxygen here and 2 here, so we need to put a 2 here. We have 4 hydrogens and only 2 here, so we need to put a 2 here. Now our equation is balanced. A single displacement reaction is when a element swaps out another element that's in a compound. So we have like this lonely A here, and it's hanging out. It wants to swap with the B in here. So A plus BC makes B plus AC. So now we're going to try that. So an example of this could be like sodium reacting with like magnesium chloride. And that can form sodium chloride plus magnesium. So you can see that the sodium swapped out the magnesium in the compound. So again, we have to check to see if it's balanced. So if you scan through, you see there's 2 chlorines here, but only 1 here. So we need to put a 2. So now there's 2 chlorines, but now there's also 2 sodiums. So we need to go over here and put a 2 here. So that's a single displacement reaction. In those reactions, you'll see an element plus a compound, and then a compound plus an element on the other side. If you're thinking of this as an analogy, you could imagine that this person here steals this person's boyfriend or girlfriend and takes them away. A double displacement reaction where elements in 2 different compounds trade places. So this element is going to swap with this element. You could almost think of it as 2 couples showing up at a dance and then trading partners halfway through the night. So that's a double displacement reaction. So we would represent it with AB plus CD makes CB plus AD. So you can see that A and C have traded places. So an example of this one could be lead to nitrate plus potassium iodide, making lead to iodide and potassium nitrate. So you can see the lead and the potassium have traded places on the other side. So this reaction isn't balanced. We have 2 nitrates here, so we need to have 2 over here. So we'll put a 2 there. And then that makes us have 2 potassiums and 2 iodines on this side. I've got to fix that. And then we'll put a 2 here. So now our equation is balanced. So a double displacement is a double swap. Our last example is a combustion reaction, and that's when there's a reaction between oxygen and another element or compound. So the example that I have here is magnesium plus oxygen making magnesium oxide. That reaction isn't balanced. We have 2 oxygens here, so we need to put a 2, we'll squeeze it in, and then we need to put a 2 here. Another type of combustion reaction could be methane burning an oxygen. So whenever you have a hydrocarbon reacting with oxygen, your products are going to be carbon dioxide plus water if it's a complete combustion. Other products will be produced if there's not enough oxygen. So carbon or soot could be produced if there's not enough oxygen, and another compound that's toxic to us, carbon monoxide, could be produced. So this reaction isn't balanced. We need to balance it out. So we have 4 hydrogens over here, but only 2 here. So we need to put a 2 there. So now that makes 4 hydrogens, but then 1, 2, 3, 4 oxygens. So we need to put a 2 beside that one. So now our equation is balanced.